Hello everyone, this is Ashraf and welcome to this tutorial. Today I will walk you through a Grasshopper script that I previously created for a Voronoi pattern. This pattern can be a ceiling, walling, or flooring, and I will explain each step so you can understand how can you customize it and apply it to your projects. So let's get started. So let's start with an empty Rhino file and completely new. First, we need to open a Grasshopper plugin. Here I'm using Rhino 8, and I prefer that if you are going to follow this script, Rhino 8 is recommended. So let's start with the curve. This curve basically it will be our base geometry. Let's draw a curve. Where is curve? Rectangle. Yes, rectangle. This rectangle can be, of course, horizontally and vertically. It's depend on your project. In this case, I will explain it in a horizontal way as flooring or ceiling. So we will click the curve and now it's applied in Grasshopper. Then we need to convert this curve to I forgot to okay, some music. Okay, so this is the surface that it comes from the curve that we draw. This curve is completely depend on your project. When you move it, feel it in or out, the surface will be applied. Okay. We need to do one step before that surface that we need. It's very important step. I will explain to you why. So I'm planning to remove a Voronoi or wait a second. Let's have it here. Yes. So let's assume this is our border for the pattern. I need to create inner size just okay to have like safety margin for the border to avoid any pattern that could be in this area. So let's get back to our script. So this component, let's have bifocals. Bifocals, this plugin is very important. You can read the key or the name of the component. So let's put it there. The offset, this line, I want it to be inside inward offset. So simply the distance set number minus x. Minus x, it means just checking if the mic is working. The next step will be populate geometry. Populate geometry, it helps that you can have multiple randomized points over all the surface that we created. This one. So I think let's reduce the counts to avoid any crashing that could happen to the software. No, let's make it 50. Okay. Just a second. So from this point, we will get the Voronoi component, which is there. Let's connect the population point, which is 50 points, as we decided over here. And this component, the Voronoi, it's what we have here. In this component, you need to do one more step. to define the boundary, which is like a limit for this pattern. In this case, our limit is the offset one. So connect here. So we will have the Voronoi, as you can see here. We did one mistake that this void, it should not be like this. We need it as a solid. So simply we will connect this curve to that surface. So as you can see now, you have a clear margin all around the Voronoi pattern. My advice to you that for the scripting in Grasshopper, don't forget to group each step or each section for the script, just to keep the algorithm or the scripting file organized all the time. So what we have now, the Voronoi, let's hide this. So now you can have it clear Voronoi without any other items that you don't need it for now. So we will connect the Voronoi to the area. This plugin, this component, it helps to identify the exact centers of each cell for the Voronoi. As you can see here, if you just hold the mouse, the cursor, you will find 50 cell, which is 50 point that we previously in the count that we mentioned in the count. So the second part is we need to have a random circles or a random points, so we can customize the area between these points as per our own. So let's draw a circle and copy it in different locations. Let's get it selected by multiple curve 1, 2, 3, 4 and right click for enter. So we have the centers for the Voronoi. Again, we need the centers for these circles, and the closest point for this circle connected with the cloud. As you can see, this component, it helps that it can identify for you the closest point to this circle. As you can see, 1, 2, 3 points is the closest point to the circle, and this circle, this point. Now we can also customize the numbers of the closest point that we want. For example, if you reduce this, the point will be reduced. For example, this is number 1, so only 1 point that be highlighted for the next these circles. And the more you are increasing, the more points will be highlighted. So let's keep it for now at 2 points only. So this part done, and you can change the color here. Okay. So what I want to do is to keep this point, the highlighted point, as a solid. I don't want to have any scaled or any voids around these circles. I just want to keep it as a solid. This helps if you want to add a column or any object item on this area as a wallpaper, TV or something, so you can clearly have this as a solid with no voids or a pattern. So to do this, we already have the points, so let's have this component which help us to remove this point from the overall pattern. So this pattern, we will connect it to the list, and the indices to the index from the closest point. So then this list, it helps to highlight the overall pattern without this closed point. But there is one step that we need to do it, which is to make this as a flatten. You see the dotted connection? Dotted connection or dash connection means it's a graphed, not flattened. To have it a flatten, just from here centroid to make it flatten, then here as a flatten. So as you can see now, this line and this line, which that means has been excluded. So let's start with the third part. Third part is to create the offset. So this is our Voronoi cell. We need to do an offset, so we can have a void here, and to make this as a solid. Again, we have area to have the center. This component is very important and useful, and we want the list length to have it as a random. Okay, so we need to. So next, scale component from the center to the center, and the geometry is this. As you can see, all the Voronoi cells have been scaled, excluded the point which we excluded previous part. Once you increase this slider, the Voronoi will be vanished. So let's keep it as 2. The scale, we need to add more, some dramatic effect and randomized numbers. We need to domain, construct domain, sliders 0, 0.5 to 0.9. This means that you will start from 0.5 and end with 0.9. Once, and you can play with this. The less number, it means the bigger openings. Okay, so as you can see, there is no randomization. So to have the randomization, we can simply apply a random component, connect the domain to the range, the factor, and list length, just to put it in numbers. This number, this box, the random component is, and you can find it there. It helps to create a group of randomized number from start to end. In our case, it's from 0.2 to 0.9, but it needs number. The number is the list of the centered. How many centers we have? Like we have, for example, 42 centers. The 42 centers is the total number for this box, and you give each element in this numbers a specific domain, which is 0.2 to 0.9. So if you try to change something, it will affect in random way. Then let's make sure that the curves are joined properly, so we can have the fillet component. The fillet component need a radius. The radius, so you can, as you can see, you can have a smooth line, or you can just keep it without any fillet applied. So let's group this up. Change the color. So the third part done. you want, you can hide this and hide this. If you want to test it, see if you move the circle or the attractor objects, the pattern will be changed. So what I'm looking for, to have this area as a solid without any pattern, without any openings, in case I have a column conflict with this area, if I have a wallpaper, artwork, and extra. Just let's keep it like this to have a better review. Now the last part is fun and the baking, the final output of the object. So what I want to do is to create a base surface, and the second two surfaces. One surface is the main surface, and the second surface is in between surface. Let's hide this in between surface and the voids, the pattern itself. So we can cut the outer surface from the inner surface. So let's have this surface number 1, and this surface number 2, and this is our base surface. There is a solid difference. It means B rep A, which is the lower one, the main one, and B rep B is the second one. So if you hide this and hide this, now you can see that you have a clear surface without the opening. If you try to move this, it's applied as a new attractor locations. So the final 2 steps is to have the offset surface. Offset surface is external plugin called Pufferfish. Pufferfish, you can find it and download it from Food for Rhino website, and I will keep it in the description below. Let's have it as a 0.5, let's say. Now use it. Okay, this is good. Or just okay. So the last step is the shrink wrap. It's a very useful, and it's a new feature for Rhino 8. Just only in Rhino 8 you can find this. In case if you want to have the edges as fillet with the below edges. As we can see now. So let's apply it, but be careful because it might take time. You need to have a good PC or laptop. So this is like an initial number that I can start with. So let's see. As you can see, it has been filled. So the more you increase, the more enhanced shape you will have. So just to save our time, I will keep it like this. So any question that you have, let's scope this up. So this is the last part. So this script is basically 4 sections. Okay, I hope this tutorial was helpful. If you have any question or want to see more tutorial like this, let me know in the comments. Don't forget to like, share and subscribe for more Grasshopper content. Thanks for watching and see you in the next one.